Hi, welcome to another 4AC learning video. In this video, we look at example 2.5b, which is found in your lecture notes. For this example, it reads, find the sinusoidal expression for the current IS, that means the total current coming into this circuit, shown below, and sketch the phasor diagram if the branch currents are all given there. If the third branch current flows through a pure resistor, what do you think are the components of the load in the branch for I1 and I2? And what components does the overall impedance of the system comprise of? Let's see how do we answer this question. Now, in this question, we shall use Kirchhoff current law, which states that the current coming into a node S is equals to the current flowing out of the same node. So this is I1, this is I2 plus I3. Or in the phasor version, we say IS is equals to I1 plus I2 plus I3. Right, so in order to do this analysis, the first thing I would like to do is to convert every one of these waveform into the phasor equivalent. So in this case, I1 is 6 over root 2 angle 30 degrees milliamps. I2 is 8 over root 2 angle minus 30 degrees milliamps. And I3 is equals to 10 over root 2 angle 0 degrees, right? Because there is no phase angle there. So for this, if I want to find the total current in phasor format, I need to add them up, right? 6 over root 2 angle 30 degrees plus 8 over root 2 angle minus 30 degrees, and finally 10 over root 2 angle 0. Now for phasor, I can't just add like that, so I have to convert all to rectangular format, right? Then I sum them up together. So for I1, I will have 6 divided by root 2, which is 4.243. 4.243, convert it to rectangle, 4.243 at an angle of 30 degrees. I should get 3.675 plus J 2.122. I2 is 8 divided by root 2 is 5.657 at an angle of minus 30 degrees. That will give me 4.899 minus J 2.829, and finally I3 is 10 divided by root 2, which is 7.071. Now all I need to do is for IS, I need to sum everything up, right? So I will get 3.675 plus 4.899 plus 7.071. That gives me 15.645, and on the imaginary side is 2.829. That's minus J 0.707. Convert that to phasor, to polar format. 15.645 comma minus 0.707. That's 15.66. Finger off. Minus 2.59. Nearly M. Okay, so that's in the phasor form. Now, if we are told that I3 is a pure resistor, right? So this is a pure resistor. Then I can find the voltage Vs, because Vs is I3 multiplied by the pure resistor, which is and I know Vs, I know Is. So if it's a pure resistor, that's why I have 0. That means the phase angle of Vs is also 0. Right? That means Is times R with a phase angle of 0. Now if Vs phase angle is 0, then if I look at I1, now I1 has a phase angle of 30 degrees. That means tells me that the load in I1, or flowing through by I1, is an inductive load. That means resistor and inductor. Whereas in load 2, where I2 flows, because it's of the negative 30, so it's a capacitive load. It means a resistance plus some capacitors. Okay. Whereas for the overall impedance Z, I can conclude, right, because Vs over Is, I can conclude that the impedance must be a positive, right, 2.59 degrees. That means the voltage leads the current by 2.59. So overall it is a inductive circuit, inductive load. That means more of R plus L with a smaller C, right? So that's how I would interpret this part of the question. If I3 flows through a pure resistor, right, what do you think are the components of the load that I1 and I2 flows through? So I1 flows through there is inductive load because of the plus 30 degrees, whereas I2 flows through a load which is more capacitive in nature because of the minus 30, and the overall impedance end up is positive, because if here is 0 and here is minus 2.59 degrees, it's a positive impedance. So it tells me that this is a inductive load because the voltage leads the current. I hope you learned something from this video and something about inductive load and capacitive load based on circuits in parallel. Bye bye.